All right, I'm going to be going over the solutions to the Chapter 5 review. So here's our first problem. So we're going to be writing the equation of a line in slope-intercept form that passes through these points. So remember slope-intercept form. We can find slope in a few different ways, so I'm going to do it in two different ways here on these problems. So first way, I'm going to go ahead and look at these points, and I'm going to create a small table. There are many ways to find slope. This is just one way. So we have -2, 9, 1 minus 3. So slope is the change in y over the change in x. So my change in y, I'm going from 9 to -3. That's a decrease of 12. And my change in x, I'm going from -2 to 3. That's an increase of 3. So slope is change in y over change in x, which simplified and reduced is going to be -4. We always reduce our slope into simplest terms, so either a whole number or a reduced fraction. And then the next part we need to figure out is our y-intercept. So what we do there is we use one of our points in our slope to plug in for y, m, and x, and that allows us to solve for b. So I'm going to go ahead and do that. I'll use this point right here as my x and y, and obviously m, we just found that. So my y is 9, m is -4, x is -2, and then I'm solving for b. So it's a pretty simple equation. We get 9 equals 8 plus b, and then subtracting 8 from both sides, we get 1 equals b. So that gives us our slope and our y-intercept. So the equation of this line in slope-intercept form is y equals -4x plus 1. That's it. And for the second problem here, I'm going to write an equation of a line through these points. So same idea, I still want to write it in slope-intercept form. A lot of it's going to be the same. I'm going to go ahead and show finding my slope in a different way. So I can also use what's called the slope formula, which is y2 minus y1 over x2 minus x1. So I'm going to call this point x1, y1, and this point x2, y2. Doesn't matter which way I do that. This one could be x1, y1. This one could be x2, y2, or like they are. It just doesn't matter. I just need to do this subtraction consistently. So y2 is 11, y1 is 7, x2 is 3, minus x1 is -5. Okay, so that's going to be 4 on top. My change in y is 4, and my change in x here is 8. Reduced fraction, these are both divisible by 4, so my slope is actually 1/2 for this problem. Okay. And then I know my slope, so the only other thing I need to know is my y-intercept. So I'm going to use one of these points. I'm going to use this one because I'm dealing with positive numbers. So I end up with 11 is my y equals 1/2 times my x, which is 3 plus b. This one's not going to work out as nicely, but it's still fine. 1/2 times 3 is 1.5. I could do that as a fraction if I want to too, but I think it's easier to think about it as this decimal. Subtracting 1.5 on both sides, I get 9.5 for my y-intercept. So when I go ahead and write my equation, 1/2 x plus 9.5, or if I prefer to keep it all fractions here, I could do that as 9 1/2 or 19 over 2. Whatever my preference here is, I'm just going to leave it as a decimal, but it doesn't really matter. All right, so that was a little different because of the way I found slope. All right, and then we are going to be writing the equation of a line from a graph. So again, still writing it in slope-intercept form. So I need to know what my slope is and what my y-intercept is. The y-intercept's pretty easy. It's 5, so it's going to be +5. where the b is. And then for slope, I need to, since I'm on a graph, I'm going to use what's called a slope triangle to go between 2 points. So I'm going to be going up 4 and over 3. And both of those are positive, right? Going up 4 is positive, and going to the right 3 is also positive. If we went to the left, that was negative. If we went down, that was negative. Anyway, slope is rise over run, or vertical change over horizontal change, or change in y over change in x. It's 4 over 3. You'd want to reduce that, but this is in reduced form. So that is our slope, and that is our equation. Y equals 4/3 x plus 5. Slope between any 2 points should be the same. So if we chose other points to do it, we could have gone from here to here. We should get the same slope. This is an increase of 8, and this is an increase of 6. And when we do 8 over 6, that reduces to 4/3. Or if we went the other direction, instead of going left to right, if we went right to left, really similar idea. I could be going down 4 and left 3. So down 4 and left 3, those are both negative. Negative 4 over negative 3 is 4 over 3. Between any 2 points, any direction, we're going to get the same slope. So just make sure you're careful with your signs and reducing your fractions. All right, let's go ahead and write the equation of this next line. Start with the y-intercept. In this case, it's 2. So plus 2 is our y-intercept. And then slope. In this case, our line is going down and to the right. This is a negative slope. Again, I can pick any 2 points I want. I'm just going to do it here. I'm going to go down 3, right 1. So down 3, right 1. I deleted one of my arrows. Down 3, right 1. So that's a negative 3 because I went down, and that's positive 1 because I went to the right. So negative 3 over 1 reduces to a whole number of negative 3. So that is my slope. And there is the equation of this line. Now, similarly to what we were talking about on the last one, we could do some different things with our slope here. I could have gone like down 6, right 2, still reduces to negative 3. I could have done up 6, left 2. That's still the same thing. That's 6 over minus 2 still gives us negative 3. So we still get that same equation of negative 3x plus 2. That is the answer here, regardless of how we calculate that slope. I could have also done like slope formula or made a table, but I think the slope triangles on the graph are the easiest. All right, and then the last thing with lines that we have here are substitution and elimination for solving systems of equations. So these 2 problems here are substitution. I know they're substitution because one of our equations is set up nicely to do so. I have that x is equal to this, so that means I can take this and replace x with it wherever I want, and I want to do it in the other equation. So that becomes like this. I'm just going to go ahead and leave a big open parentheses where I want to actually make that substitution. I'm going to replace the x with 4y minus 6. This gives us an equation that only has y in it, and we can go ahead and solve that just like a normal equation. I'll start this solving process by distributing. I get negative 16y plus 24, distributing that negative 4, plus 3y equals negative 28. Then I need to combine like terms, negative 16 and positive 3. Those are both y terms, so they go together to be negative 13. And now we need to start solving, getting y all by itself. So I'll subtract 24 on both sides, and I miswrote that other side, didn't I? There we go. Should be minus 28. So I'll subtract 24 on both sides, leaving me with negative 13y equals negative 52. And then to finish this off, I'll divide by this coefficient of -13 to get myself 1y, and do that on both sides. So I get y equals 4. Negative divided by negative is positive. So that is half of our solution, right? A system of equations should have two solutions. It should have an x and a y. So we have the y solution. And we need to finish this off by figuring out what x is equal to. So we will substitute again. We'll substitute this number in for y. We can do it in either equation. This first one is a little bit easier. When I plug that in here, I can just sort of calculate what x is equal to. So I will do that. This becomes 4 times 4, because that's substituting for the y. And 4 times 4 is 16. Minus 6, I get x equals 10. So my x solution here is 10. And this is our solution written as an ordered pair. This is the point where these two lines would actually intersect. Great. So that was one of these two problems. I'll go ahead and do the next one here in just a second. All right, so our second problem here, again, substitution method. We know that substitution is a good method for a problem when one of our equations either states y equals something, allowing us to make a substitution for y, or like we saw in this other one where it said x equals, and then we can make a substitution for x. So in this case, y is equal to 3x plus 2. So where the y is in this equation, I can replace it with 3x plus 2. So I'm going to go ahead and rewrite that first equation with some open parentheses for my substitution. Again, I'm replacing y. Do be careful, make sure you substitute for the correct variable. So y is equal to this, so I'm replacing y. So again, right here where the y is, I'm putting in 3x plus 2. Now this is an equation that only has x in it, so I'm solving for x at this point, and I'll go ahead and do that. Okay, and then we need to combine like terms. And then solve for x. So I need to subtract 4. Subtract 4. I get that x, 1x is really the same thing as x equals 10. So remember that is part of our solution. That is our x for our solution. And then we need to take that value and plug it in somewhere, one of these two equations to solve for y. I like this second one. If I put a 10 in here, I can just calculate what y is equal to. So y equals 3 times 10 plus 2. That's 32. Y equals 32. So there is our solution, our x, y coordinate point where these two lines would intersect each other. All right. And then the second way we talked about solving systems of equations is by elimination. So elimination is when we combine two equations together, either by adding them or subtracting them, such that one of our variables eliminates, cancels out. Now, before we can do that, we usually have to change one of the equations at least, maybe even both of them, by multiplying by a constant. So what I like to do is figure out which variable am I going to eliminate. So I look at my x's and I look at my y's. So all right, so here's my x's. I have 10x and negative 2x. What I want is 10x and negative 10x. Can I easily turn this into negative 10? Answer here is yes. If I multiply this by 5, that's going to give me negative 10x. That will cause my x's to cancel, leaving me with an equation that has only y in it. That's the elimination step. If I can get that 10x and negative 10x to cancel these out. So I do this, and let's see what happens. I didn't bother looking at the y's in this case since x's could eliminate. Obviously, if I look at my y's here, I have negative 2y and negative 9y. This one being negative 9, it's not particularly easy to turn this into positive 9. In fact, there's no way to do it with a whole number. So y's altogether will be a little more complicated. So I'm going to leave that one alone and just do it the way I decided the first time. So I'm multiplying this whole equation by 5. That means every part of it, distributing it to all parts on both sides. and then I add my two equations together. And this is our elimination step, 10x, negative 10x. The whole point of that multiplication, these cancel, 0. Okay, so then we get negative 47y equals 94. Divide both sides by negative 47. I get y equals minus 2, negative 2. So again, that's only half of our solution, so we do need to know what x is equal to as well. So I get to pick either of these equations, substitute negative 2 for y, and figure out x. I'm going to go with the first one. So 10x minus 2 times y, which is minus 2, equals 44. Okay, 10x plus 4 equals 44. And then subtract 4. 10x equals 40. Divide by 10, I get x equals 4. So that is my solution, 4 comma negative 2. Ordered pair is generally the preferred way, and I believe on the test the way that I ask you to write your solution. All right, now the second problem here. Again, we want to kind of do a little work in the beginning to figure out which variable is easier to eliminate. So I'm kind of looking at my x's first. I have negative 2x and 9x. I can't turn a negative 2 into a negative 9 very well. I could change both equations. Like I could multiply this one by 9 and this one by 2 so that I got negative 18x and 18x, right? That's always an option for me to multiply both equations, but that's a little extra work. Let's see if y eliminates a little easier. So in this case, it does. I have 9y and negative 3y. I can easily make that one negative 9 just by multiplying this equation by 3. If I multiply this one by 3, I'm going to get negative 9y, 9y. Those will eliminate. So let's go ahead and do that. Negative 6x minus 9y. 3 times negative 9 is negative 27. Okay. Now let's rewrite my first equation. Or sorry, my second equation here. And then I'm going to add these two together. That is 3x. Here is our elimination. Those cancel out. And that equals negative 27. Divide by 3. I get x equals negative 9. Cool. Awesome. Got my first solution. Now we need to pick one of my two equations to substitute negative 9 in for x. Let's go with the second one. Let's just go ahead and do the second one. So that's 9 times negative 9. That's 9 times x plus 9 times y equals 0. So I get negative 81 plus 9y equals 0. I'm going to add 81 to both sides. Get rid of that 81. I get 9y equals 81. And from there, I'll divide by 9 and get y equals 9. 81 divided by 9. So that's my solution, xy, so negative 9 comma positive 9. That is our ordered pair where these two would intersect. There we go. All right, so I'm going to go ahead and stop the recording here and start a part 2 for the chapter 5 review.